Hi everybody, we're going to keep talking about thermochemistry, so I'm going to go through this pretty quickly. Just remember that you can pause the video. So last week we were talking about molar heat, the heat required to melt a mole of stuff or vaporize a mole of stuff. So we learned that the molar heat of fusion for water is this value, molar vaporization for water is this value. Remember that every substance has its own molar heat, so we learned that ammonia has a different molar heat. Methane has a different molar heat. So what we're going to talk about today is how were those numbers actually determined? So how did they come up with that number and that number? So was it an instrument? No, they didn't use an instrument. They used a calculation. So there was a kilojoule value that was divided by a mole value. That's why we have these units here. So how was that kilojoule value actually determined? So it wasn't with an instrument, that was with a calculation as well. So remember this, that energy flows out of one substance and into another substance. So, for example, let's say we have a mole of substance here. Energy is flowing out of the sun, in this example, into 1 mole of solid substance, and that is now melted. So this was kilojoules of energy, but how much is that, and how did we determine that, since there is no instrument that measures kilojoules directly? Okay, so the calculation that we use to come up with kilojoules is based on 3 variables. And these are the variables. So we can put all of those variables into an equation. There we go. And here's what the equation looks like. So the letter Q, which is lowercase, that is our value in joules or kilojoules. Remember, kilojoules is just 1,000 joules. M should be familiar. This is our mass, which we measure in grams. CP is called specific heat. This is going to be something new. Specific heat. And that actually has 3 units on it that we'll look at in a minute. So delta T is a difference. We've seen that triangle a bunch of times, and we're going back to difference in temperature. Okay, so here's something that you have to watch for, is that this can be in degrees Celsius or Kelvin. So something that trips people up a lot is that they want to add 273 to your degrees Celsius, but you don't actually do that because we're talking about a difference in temperature. So let me put this note up here. Don't add 273. And here's why. So let's say we have a difference in temperature of 5 degrees Celsius. So let's say we start at 30 degrees Celsius and the temperature dropped on a substance by 5 degrees. Well, if we add 273 to those, 273, that's 298. If we add that's 303. If we add 273 to this, that's 298. What's the difference in Kelvin? It's still 5. So if you get it in Celsius, keep your difference in Celsius. If you get it in Kelvin, just keep it in Kelvin because the differences are the same. Okay, so we should be familiar with energy in joules or kilojoules, with mass from a scale, and temperature. So what is specific heat? So here's what it's defined as: the amount of energy, which is Q, required to raise 1 gram of stuff by 1 degree Celsius. So here's a visualization of that. So we have 1 gram of stuff. So this is different from molar heat. We're not talking about melting, we're not talking about moles. We're just talking about its temperature changing. So this is going up by 1 degree because we're putting in some energy of some kind, and that 1 gram went up 1 degree. So we can measure with a thermometer temperature change, but we have to use all 3 of these variables to actually determine its specific heat. So we can actually find the specific heat of common substances on a chart. So I'm putting this chart on my website for you to look at. But here's water. Water has a specific heat of 4.18 joules for every 1 gram going up 1 Kelvin degree. So if this was water, say it's liquid water, in order to go up 1 degree, we have to put in 4.18 joules of energy. Now look at some other substances that we're familiar with. Copper. Look at how low that is. It only takes 0.385 joules to make 1 gram go up 1 degree. Other metals have really low specific heats. In fact, water has the highest specific heat of all liquids, and there's only a couple of substances that are higher than water. Okay. So I'm going to have a second video on how to use this equation, so follow that link.